All right, as we come to 745, you've now seen how to calculate the slope of a line on a graph. And I'm going to demonstrate with the 2 points that are right here. If we want to find the slope of the line that connects the 2 points, 6, 5, and 3, 7, you can see I've identified those 2 points here on the graph, and I've drawn my line. What we've been looking at is always start with our leftmost point here, and we're going to move to the rightmost point here, our next point over. And I'm going to ask myself, how am I moving? Am I going up or down? Well, to start off, I'm going to be going down. So I use the symbol negative because that means down. Down how many? Well, this is down 2. And then we're going to say over, and we count how many that is. That's over 1, 2, 3, so over 3. Therefore, my slope of this line is down 2 over 3. And we can't reduce that fraction anymore. Negative 2/3 is as far as it goes. So we know the slope of this line is negative 2/3. What if I asked you to calculate the same exact slope without using a graph? And you'll understand why I need you to be able to do that in a moment. But let's just do it for a second. What's another way that I could use my y values, all right, here and here, in order to get this value of negative 2, that change? Well, we can simply take where we ended up, which is this one right here, 5, and I can subtract where we started from. All right, 5 minus 7. We see that 5 minus 7 is indeed negative 2. It shows that when we got to the new point, we had lost 2 from our original point. So I took my new y, something known as my second y value, or y2, and I subtracted the first y value, y1. All right, let's do the same thing for the x. What if I want to see how did I go from 3 up to 6? Well, I can take where I was at 6, and I could subtract where I started at. So 6 minus 3 gives me 3. All right, and that's my second x value, known as x2, minus my first x value, x1. Now, these tiny little numbers down to the right of my variable, x2, x1, they are not exponents. Exponents are above, top right. This is what an exponent looks like. It's up high. All right, I'm looking at x2. It's called a subscript. It means it labels that variable for me to make it more specific. So in this case, I have 2 x values. So x2 means the x value of my second point, the one I'm traveling to. This is point 2. And the x1 means the x value of my first point, the point that I started at. All right? And same with y values. y2 would again come from my second point. y1 would be the y value of my first point. So it's merely a subscript to label. It is not one of these. It's not an exponent. So just cross that off. All right, so that's how we can do it. Let's see why we'd need to do it and give you a better example. In this case here, they ask us to find the slope of the line connecting 415 and 211. Well, 415 is going to be a much larger graph than what we're used to. And so I don't necessarily want to have to plot those 2 points on the graph and then calculate my slope up and down. So again, we can use what we just identified. We learned that the slope of any line can be determined by taking the second y value minus the first y value. That's a way that I can find my change in y, if you will. All right? And I can put that over top of my second x value minus my first x value. That's another way that I can find the change in x without having to graph them. So in this case here, if I want to plug this in, I know that my slope is going to be my second y value. So I'm going to label that here. This is y2, my second y value. This is y1, the y value of my first point. So I'm going to take 11 minus 15. And that's going to go over top of, I want my second x value, this is x2 here, and I want to subtract my first x value. So I'm going to take 2 minus 4 in the denominator. And if I simply do that math, 11 minus 15 is negative 4. Over top of 2 minus 4 is negative 2. And I find out that the slope of this line, if I reduce negative 2 over negative 4, I end up with a positive 2. And that would be my slope of the line connecting these 2 points. Let's take a look at a bigger one. Here now, all of a sudden, they ask us to find the slope of a line connecting 2886 and 3483. I definitely do not want to draw the graph of this. But remember, my formula to calculate my slope algebraically can always be found by taking the second y value minus the first y value. That's my change in y. Over my change in x, my second x value minus my first x value. I can label those over here. My first x value is my first x point. My first y value is my first y point. And then my second x value is the x value of the second point. And my second y value is the y value of that second point. So I can go ahead and use my formula. M equals y2, which is 83, minus y1, which is 86, over x2, which is 34, just plug in these pieces in, minus, always minus there, my x1 value, which is 28. And if I go ahead and do that, I can do 83 minus 6, which is negative 3, over top of 34 minus 28, which I find out to be 6. And I can see that m equals negative 3 divided by 6, or negative 3 over 6, reduces to negative 1/2. That would be my slope of this line. This will be an important piece moving forward because we're not doing this yet. If you're up for the challenge, go for it. But if I give you these 2 points, can you get me the entire equation of the line connecting those 2 pieces? Well, those 2 points. This is the first step. Finding the slope is the very first step to that process. So get good at this. Practice finding the slope of 2 points without drawing it on a graph. That will be our first step in the process of finding the entire equation of a line. Let's take a look at one more example. In this case here, I've got my 2 values. I'm going to start by marking off my x value of the first point, y value of the first point, x value of the second point, y value of the second point, and then I'm going to plug those into my formula. All right, so I see y2 is 17 minus y1 is 9 over x2 is negative 16, and then x1 is minus negative 15. And that's why I chose this example. I wanted to point out that when you do have a negative value here, you cannot just ignore it. This minus was part of my formula. There's always a minus in the formula. So if x1 is negative, I need to put parentheses and add that negative as well. All right, so if I go ahead and simplify this, I see that 17 minus 9 is 8 over negative 16 minus 15. Well, if I take a look at that, that's really negative 16 plus 15. So that's going to give me negative 1. Therefore, my slope, 8 divided by negative 1, will reduce down to negative 8.